Do you know what today is? It's our birthday! Hi everybody and welcome to our birthday edition of Boring JavaScript. I'm your host, the Virtuoid, aka Mike Smith, and today is our 1-year birthday of producing boring JavaScript videos. That's right, it was 1 year ago this week that we produced a video on the for and the for each constructs within JavaScript, and we've been having fun ever since. Now today we're going to be talking about promises in JavaScript, but as a gift to you, because it's our birthday, I have developed a story to help explain how promises work within JavaScript. The story is called The Three Friends, and our dear friends at Shadow Wolf Studios have produced a video to go along with the story. So here is the story of The Three Friends. Sit back, relax, and enjoy. Once upon a time there was a person, our hero, who wanted a genuine handmade plunkel. The problem is, our hero didn't know how to make one. Besides, you can't make a plunkel without a boondit, and you can't make a boondit without a screepert. Whatever was he to do? Luckily, our hero had 3 friends, one who could make a screepert, one who could make a boondit, and another who could make a plunkel. Our hero went up to the first friend and said, "Can you make me a screepert?" "Absolutely," said the friend. "I'll be back in an hour." So off the first friend went, and our hero walked over to the second friend. "Can you make me a boondit?" asked our hero. "Why, of course," said the second friend, "but I'll need a screepert first." "I'll get that to you," said our hero, "once my friend has made one." Off walked the second friend, and our hero approached the third friend. "Can you make me a plunkel?" "Why, I would be honored," said the third friend, "but first, I need a boondit." "I will get you that," answered our hero, "once my friend has made one." The third friend then walked away, and our hero got to work on making a wooden case for the plunkel. About an hour later, the first friend appeared. "I have finished your screepert," said the first friend. "Thank you," said our hero, who then ran to find the second friend. "I have a screepert for you," said our hero. "Much obliged," said the second friend, taking the screepert. "I will be back in an hour." The second friend walked away, and our hero then went about working further on the plunkel case. About an hour later, the second friend came back. "Here is your boondit," the second friend said. "Why, thank you," said our hero, who then ran to find his third friend. "Here is a boondit for you," our hero said, handing it over to the third friend. "Why, many thanks," said the third friend. "I will be back in an hour." The third friend left, and our hero went about finishing up the plunkel case. About an hour later, the third friend appeared. "Here is your plunkel," the third friend said. "Oh, thank you so very much," said our excited hero. "I now have a plunkel." Our hero then proudly displayed the new plunkel in a shiny new box. The end. So for our example today, we'll use our 3 friends and our hero from the story to show you how promises work in JavaScript. But first, let's explain what a promise is. A promise is exactly what its name implies. It promises that something will happen in the future. Now, JavaScript is a single-threaded language, and normally when you are working with JavaScript and you want to go do something that may take a little bit of time, you just have to sit there and wait on it to finish up. It's like, for example, let's just say we had to read something from a file server or something like that. And what JavaScript will normally do is that we would say, okay, we need to go read that file. And the JavaScript goes off, it reads the file, and then it comes back and says, oh, I'm done. All that time you're just sitting there, wait. You know, if it's a 4 gigabyte file, it's going to take some time. So then once it reads it, it finishes up. But what promises allow you to do is say, okay, go read the file. JavaScript will then come back and say, okay, I promise that I will tell you when that file has been read. But in the meantime, you take control back of JavaScript so you can continue to do whatever you want to do. So you create a promise that basically says that in the future, something is going to occur. But for now, you can continue on working within your code. Now, a promise has 3 different states. A pending state is a state that says, okay, something's going to happen in the future, but it has not happened yet. So here's my promise. You can just continue on working. And we'll see about a pending here shortly. The other two states is the result of whatever happened to the promise. The first state is fulfilled or resolved state, and that means basically something good happened. You've gotten the data from your filer or whatever, and the promises now say, I have fulfilled myself, I have fulfilled my task, and I'm completely done. The third state is the reject state, and the rejected state basically says that, something has gone wrong. So here's an error message or something. You deal with it yourself. So those are the three states that we're going to be working with in our promises. The pending, which means nothing's happened yet, but you can continue on working. Fulfilled or resolved, which means, hey, something good has happened, we're done. Or rejected, say, hey, something bad has happened, but we're done. So in our particular case here, we're going to have a promise that is going to make the Skriebert, a promise that is going to make the Bundit, and a promise that is going to make the Plunkel, and a promise that's going to make the case, which our hero will make. So now that you have an idea of what we're going to be doing here, let's go take a look at the code. So let's take a look at our JavaScript code. Now what I have done here is I've created functions for each of the 4 different things that we have to do. I've got a function for the build Skriebert, a function for the build Bundit, I got a function for the build Plunkel, and finally a function for the build case. Now all 4 of these follow the same pattern, so we're going to take a look at the build Skriebert and just work off of that one, but just understand that all 4 of them will work in the same way. So in each case here, we need to return a promise so that our JavaScript program, when it calls build Skriebert, it will get back what we call a promise. So to do that, we return a new promise. We basically instantiate a new promise object. When we instantiate that promise object, we pass to it as its sole argument a callback function. And what will happen is that JavaScript will execute that callback function once it does whatever it has to do. And initially we'll end up with a pending state, because remember we have 3 different states: pending, resolved, and rejected. And initially we'll have the pending state. Now what will happen in our callback function is that JavaScript will pass 2 different arguments to our callback function. These are 2 functions themselves. One's called resolve and one's called reject. And this will allow us to be able to give a final resolution to our particular promise. Because remember, we have those 3 states: the pending, resolved, and rejected. Pending is automatic. That's automatically given to us. We need a way to be able to say, okay, promise you have been resolved, or promise you have been rejected. And that is the responsibility of these 2 functions, the resolve and reject function. So what I have done here is I've got a variable called completed true or false, and that just allows me to be able to determine whether we have completed the task or not. And then I have a set timeout that will execute a function at the end of 2000 milliseconds. So that's the only code that is executed by the build Skriebert program. So once it executes that code, it says, okay, I'm done. JavaScript, here's my promise, but it's pending, because that's the automatic state of the promise. And JavaScript will then say, okay, great, no problem. I'll put you off to the side and I'll continue working. Once that 2000 milliseconds is up, it's then going to execute the code that you see in front of you here. And here we basically take a look at if it has been completed, then we're going to resolve the promise, and if it has not been completed, we're going to reject the promise. And we do that by resolving or rejecting, and this will set the resolve and rejected states of the promise for us automatically. And that's why we're using these 2 particular functions up here that are passed to us in our callback method. And what we will then pass within each of the resolve or the reject functions is a variable. And what will happen is that this variable will then get given back to JavaScript as the final data for this particular promise. So the promise will have those 3 states plus some additional data. And then what JavaScript will do is it will then pass that data to other promises that are part of a promise chain. And we'll cover promise chains here very shortly in the next segment. So that's basically all there really is to a promise, is that we return a new instance of the promise. We pass to the promise a callback function, and that callback function, JavaScript will pass back to us two functions that will allow us to be able to resolve or reject the promise. It will automatically get a pending state that gets passed back over to JavaScript. And then once, in this case, the timeout occurs, we will either resolve or reject the promise, which will change the state to resolve or reject, and pass it back data that then JavaScript will use to pass to other promises within the promise chain. So build scriptbert does that, build boondit does that, build plunkle does that, as does build case. All of them do that at one. It basically does the exact same thing. So now that I've shown you how a promise works, let's take a look at what a promise chain does. That's next. So now let's put everything together and talk to you about a promise chain and then show you how this actually works. So this is a promise chain. And this is basically the proper way to use promises. Now, again, the idea here is that a promise is an asynchronous operation. It doesn't return anything until a certain point of time. So you don't want to start something until you know something else has been done. And that's what a promise chain allows you to do. So the first thing I do is I call my build scriptbert operation. And again, that build scriptbert will return a promise. Now, what will happen here is that the next instruction is a then method. And the then method basically says execute what is inside the argument of the then method if the previous promise has been resolved. So once build scriptbert has been resolved, then we execute build boondit. Once build boondit has been resolved, then we execute build plunkle. And once build plunkle has been resolved, then we execute all done. Now, also, the idea here is that when we execute anything within the then method, it will pass to it automatically the value that got passed in the resolve part of the previous promise. So recall, if you would, this build scriptbert here, when we resolved, we passed a argument here of results. And basically we marked our result for the scriptbert as being good, and then we returned that as results. So when build scriptbert gets the results back, it then will call build boondit with the results variable passed as the argument to build boondit. So build boondit will then take the results, make a change to it, and resolve or reject that. Once build boondit gets resolved, it will pass it to build plunkle. So build plunkle will then do the same thing. And once it gets resolved, it will then go to all done, which all done way down at the very bottom here will do the final same thing as it will take results. Actually, all done doesn't take any results in this case, it just finishes everything up. So that's the key here to what we call the promise chain, is that since then is not executed until the promise that it is attached to resolves itself, then we know for a fact that build scriptbert will get executed, then 2 seconds later, build boondit will get executed. Then 2 seconds later, build plunkle will get executed. Then 2 seconds later, all done will get executed. Now, what about the build case that we've got down here? Well, that's an interesting story here, because remember, each one of these, the build scriptbert, the build boondit, and the build plunkle, will all execute after, or resolve itself after 2 seconds. That's what this timeout is all about. But the case executes after 5 seconds. And I've done that to show you that build scriptbert, when it returns the promise, allows JavaScript to continue on. So when build scriptbert first comes in, it returns a pending promise. And because it's pending, it will not execute the then. And since build boondit has not been executed, that then will not get executed, and that then will not get executed. So it will immediately go to build case. So we now have the scriptbert and the case running at the same time. After 2 seconds, the scriptbert will finish, and then we'll start the build boondit. The build case has now been running for 2 seconds. Then the build boondit will finish, and we'll start on the build plunkle. The build boondit took 2 seconds, so now the build case has been going on for 4 seconds. After 5 seconds, it then builds the case, and then the plunkle finishes after 2 seconds, which is the 6th second before we get to all done. So all of that means basically is that the then method does not get executed until the previous promise has been resolved. Build scriptbert must be resolved before build boondit, and then build boondit must be resolved before build plunkle, and build plunkle must be resolved before all done. But build case is executed independently of all that. So once we got all of that done, once we execute this, and by executing it, I mean when we click on the go button, that's when it does the do build. Let's flip back over to our browser. Again, we're going to build the scriptbert. 2 seconds later, the boondit will start building. Then 2 seconds later, the plunkle will start building. But while the plunkle is being built, the case is going to finish up because it was 5 seconds. Then after 2 seconds, the Plunkel will finish up, and then we're all done. So that's what's going to happen here. Let's do a refresh, just make sure everything is ready to go here. So let's click on go, and after 2 seconds, the Screebert should show up to be completed. Here we go. We're doing the build Screebert, and 2 seconds later, yep. Now the Boondit in 2 seconds, yep. Now the case in 5 seconds, the Plunkel in 6 seconds, and hey, we're all finished up. All done is shown that we are finished. Everything worked great. The Screebert resolved itself, the build Screebert resolved itself, that passed everything over to the Boondit resolved itself, that passed everything over to build Plunkel, the build Plunkel resolved itself, that passed everything over to all done, and the case was completely independent of them all. That's why the case showed up after the Boondit was finished, but before the Plunkel was finished. So that's how the resolve all works. And again, resolve, well, if a promise is resolved, it will immediately execute the then, and this will allow you to chain a bunch of promises one after another to be able to say, hey, once this is done, then do this, then do that, then do that. All wonderful. Now, that's the resolve. What happens on a reject? What happens if a promise is reject? We'll see that next. So that's how you do promises that are resolving to each other. What happens if you have a promise that gets rejected? Well, that's another method. Recall again, as we did last time here, is that anytime a promise is resolved, it executes the then method, and that way you can chain a bunch of promises together. Well, for one that does not get resolved but gets rejected, it is called a catch. And the catch method works exactly the same way as the then method in that you pass a function into it to be able to say, hey, execute this function whenever there is a rejection of a promise. So if a promise is resolved, it runs the then method. If the promise is rejected, it runs a catch method. So in our particular case here, what we're doing is on the build Screebert and all the rest of them is that we have a completed equals true. And if completed is true, then we do the resolve. But if completed equals false, then we reject the results automatically. And once we reject them, what will happen is that, let's just assume, for example, that build Screebert was the one that got rejected. It will then get to the next then and say, nope, I can't execute the then because I've been rejected, not resolved. Well, then it does that one. Nope, can't do that one either because I've been, again, rejected, not resolved. Can't do that one, again, because I've been rejected. But I can do this one because I have been rejected. And once it gets rejected, it then executes that method. And just like the thens, you can chain a bunch of catches together. So if you need to do a number of different things, one after another, you can then get those different catches just straight down the list. So catch is used for to handle rejected promises, while then is used to handle resolved promises. So again, if we flip back to our browser, and we do a Control F5, everything still should work exactly the way it was before because everything has been completed. So when we click on go, the Screebert will be done first in 2 seconds, then the Boondit after 2 seconds, the case after 5, the Plunkel after 6, and everybody is happy. But what happens if something gets rejected? Let's say the Boondit got rejected. So, the Screebert maybe wasn't made perfectly, and so the Boondit couldn't get made. Let's flip back over to our code. And let's go to our build Boondit, and I'm going to say completed equals false. And by doing this, this will automatically force a rejection of the build Boondit promise. So now that we have that, let's see what happens. Let's flip back over to our code here. Let's do a Control F5, make sure we're okay here. So it's been rejected, so we know that the Screebert's going to be okay. So after 2 seconds, we expect the Screebert to have the check mark. After 4 seconds, though, we expect the Boondit to have something like an X mark or something like that, which means at that point the whole process stops, and then a second later we get a different type of picture on the right hand side. Let's see what happens. We click on go. The Screebert after 2 seconds, after 4 seconds, the Boondit, no, we got an error on the Boondit, and that means that the Plunkel was never executed because the Plunkel was inside the then chain and not inside the catch chain. So the catch chain printed up our sad little face here for our hero, but do notice that case still got executed correctly. Now why is that? Because remember, case is running completely independent of the promise chain. So no matter what happens here, even if Screebert ended up being the one that didn't get completed and Boondit and Plunkel never happened, case would still get built after 5 seconds. So this shows you how you can use the reject and the resolve part of each promise to be able to control the execution of all these asynchronous operations. The then allows you to control any promises that have been resolved. The catch allows you to do any promises that have been rejected. And that is the basis for doing the promises. Now there's another piece of the promise that we're not going to cover here, and that's called finally. Just like then executes on resolved and catch executes on reject, dot finally, well, is a method that executes all the time after one has been resolved or rejected. But we're not going to cover that. You can go look that up in documentation. So that basically covers promises, for lack of a better term there. A promise returns 3 different states: a pending, a resolved, and a reject. We control when to resolve and when to reject. And when it gets resolved, it follows the then path for you to be able to build up a chain. And then when it gets rejected, it follows the catch path. And that basically covers everything for a promise. And that's all there is to promises on our very first birthday video for boring JavaScript. Again, many thanks to our dear friends at Shadow Wolf Studios for providing the animation to our story today. Check out all of our videos at www.boringjavascript.com, subscribe to our YouTube channel, or check out everything we have at www.thevirtualvoid.com. Thanks again for watching, and we'll see you later.